Hi everyone. So we learned perfect squares and perfect cubes in our last class. So today we are going to try to identify perfect squares and cubes from different exponents. Okay, so what do I mean by that? So in perfect squares, we've learned that the power or the exponent is going to be 2, and in perfect cubes it's going to be 3. But sometimes, as you see, we are going to be walking through 4 examples here. So sometimes it's not clearly visible at first that it is a perfect square or a cube, but if we try to rearrange it, then it might turn out to be a perfect square or a cube. Okay, so for first example, we have 5 to the power of 4. So we can write it in the expanded form, 5 into 5 into 5 into 5. Okay. So what we can see is we can make pairs of 2, right? So one pair of 5 and another pair of 5, right? So we can write it as 25 into 25, right? So what does it mean? It becomes 25 square. So this is a perfect square, okay, because 25 is an integer and the square of integer is perfect square. Okay, so similarly here in 8 to the power 6 we can write 8 8 8 8 8 and 8. Okay, 6 times. So this can turn out, one is we take pairs again. Okay, so we have 3 pairs. Okay, so it comes out to be 8 into 8, 64 into 64 into 64. It comes out to be 64 cube, right? But there is another way to do this. Okay, so 8 to the power 6, 8 into 8 into 8 into 8. Okay, so we made pairs of 2's and this came out to be this. But we can also see we could have made pairs of 3, right? So one pair of 3 and another pair of 3. Okay, so in this case, okay, so what is 8 cube? So 8 into 8 is, we know, 64, and 64 into 8 is what? 512. Okay, into 512. So it's coming out to be 512 square. See? Okay, so it can either be a perfect cube or it can be presented as a perfect square. So it's easier. So you see, right, if here we could have not done that, because if we formed a group of 3, then this would have been alone. Okay, so squares have to be in pairs of 2 and cubes have to be in pairs of 3. Okay, so we could have only made pairs of 2 here. Okay, so now here we can see 7 into 7 into 7 into 7. So similarly we can just make groups of 2. If we try to make it a group of 3, then one will be left alone. So 7 sevens are, what will it be, 49, and then 49 we can write as a 49 square. So it's a perfect square. So here we can also say if, yeah, it's a perfect square of 512 or it is a perfect cube of 64. So both are correct answers. So here 3 to the power of 9. Okay. How many do we have here? 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. So you see, right? It's 9. So these are 9 times. These are odd times. So we cannot make even pairs, right? If we try to make 2, 2, 2, 2, then one will be left out. So we cannot form it as a square. Okay, so let's try to make group of threes. So one group of three, one group of three, and one group of three. Okay, so try to calculate how much is it. 3 into 3 into 3. Just think and try to come up with the answer. You can pause the video and try to solve it yourself. So 3 into 3, 9, and 9 into 3 is 27. Okay, so it comes out to be 27 into 27 into 27. So 27 cube. So this is also a perfect cube. Okay. So just giving you an example, suppose it was 3 to the power 11, right? So there would have been, suppose, two more threes. Okay, two more threes, for example. So we could have made group of 3, then this group of 3, but these two would have left. Okay, so in that case we can say 3 is to power 11 is not a perfect square or a cube. Okay, because we know if it is odd power, we cannot make powers of 2. There will be 1 because there will be 11 of 3s, right? So 1 will be left out. Okay, so we try to make pairs of 3 in this case also. So we try to make pair of 3, 3 and a pair of 3, but 2 are left out, right? So for it to be a perfect cube, we need to have all pairs of 3s. Okay, so we can say 3 is to the power 9 is a perfect cube. However, 3 raised to the power 11 is not. Okay. If you have any questions or doubts, please feel free to reach out in the comments below. Thank you for watching. See you in the next video.